Hey, chemistry, it's Friday the 17th of April. And we're going to do some stoichiometry. Isn't that great? We're going to use these concentration equations and plug them into stoichiometry. Sounds like fun, fun, fun. Page 427, number 25 and 26. Here we go. Got to have your calculator, got to have your periodic table and all that stuff. How many milliliters of this stuff are required to react with that many milliliters of that stuff if the products are those things and that thing? Okay, we got to write the balanced chemical equation first. H3PO4 reacting with BaOH2 and it produces barium phosphate and water. Now, if we look at our periodic table and our, you got one here. There we go. That bad boy. We're going to find out that phosphate is PO4, it's 3 negative. And barium on the periodic table is 2 positive. So crisscross that bad boy. Got that? Boom. Water's written correctly. That one, they gave it to us, so it must be right. And the other one they gave to us, so it must be right. So we'll leave them alone. Let's balance it. We're saying we're going to do oxygens last. We'll do hydrogens next to last. So let's do barium to begin with. 1 barium, 3 bariums. Phosphorus. Let's do phosphorus next. We got 2 phosphoruses there, and we got 1 here. Okay, now let's take the hydrogens. We always do oxygen last. We've got 6 hydrogens, and we've got 6 more, because 2 times 1 times 3 is 6. 6 and 6 makes 12. Now we got 12. Okay, and then oxygens, we've got 8, and we've got 2 times 1 is 2, times 3 is 6. We got 6 and 8 make 14. And here we've got 8 and we've got 6. That makes 14. So that's what it is. Isn't that nice? And I'm going to erase this in case I need to use that spot up there for mass. What does it want to know? How many milliliters of this stuff are required? Oops, that's not a very good question mark. Okay, is milliliter sounding like liter? To react with 250 milliliters of that stuff. If the products are that. Oh, I see where they gave us one more piece of information at the beginning of the problem. 0.75 molar phosphoric acid. Okay. Oh, and we got 0.15 molar. Okay, now the question is this. What is the formula for molarity? Isn't molarity equal to moles per liter. Well, let's take the stuff that we do have and plug that equation, because this includes stuff that we do not have. We'll do that after the fact. So the molarity is 0.15. Moles is what we're trying to find out. And the liters is 1, 2, 3 bunny hops divided by 1,000, 0.25. So the moles is 0.15 times 0.25. That's 0.0375. Moles of VaOH2. Let's put that right here. Why do we write that right there? It's because I told you to. You always put moles underneath the equation. Why did they give you all of this stuff? They gave you all of that stuff so that you could come up with moles. And as you come up with moles, you can stick it right there. Got it? Now let's do our stoichiometry. Question mark moles. How many steps? Going from here to there? One step. So we're going to do some stoichiometry next. I'll put it right down here. I'll put it in red. 0.0375 moles of VaOH2 parentheses moles VaOH2. Put that down there so it'll cancel. And what's at the end of the arrow? Moles of H3PO4. Is it going sideways? Yes, it is. Then we use these things, the coefficients. And there's a 3 that goes in front of this. And there is a 2 that goes in front of that. Moles of barium hydroxide cancel. And moles of phosphoric acid are going to come out. So we're going to multiply that times 2 and divide by 3. We're going to get 0.025. Wow. Let's go ahead and take this. With 0.025. What's our formula for molarity? Okay. What molarity did we want on this? What were the moles we calculated? How many liters? Unknown. We're going to cross multiply. There's an invisible 1 right there. And we're going to get 0.075. I'll go into a different color. Green. We're going to get 0.075 times the number of liters. We'll call that X because you guys like X's. And that equals 0.025. Now divide both sides by 0.075. And you're going to find out that X is going to equal, I can do that in my head, 0.33. And what unit would that be? What unit is called for this down here? Liters. And so that's 0.33 liters. Change it into milliliters because that's what they want. And you're going to have to move the bunny hop 3 to the right. 3 to the right, not to the left. Or you can go ahead and do the unit cancellation. On down here, you're going to say 1 liter down there is 1,000 milliliters up there. So you're going to take 0.33 times 1,000, and you get the answer is 330 milliliters of phosphoric acid is required. 330. I'm going to look at the answer. It says I did something wrong. It says 33 milliliters, 33.3 milliliters. So I got 1 decimal point off. Have you ever done that? Of course you have. And so the molarity, 0.15, 0.75, 0.75, 250 milliliters. 250 milliliters. I guess this is the only problem we can get done. That's 0.25 times 0.15. 0.25 times 0.15. 0.0375. That's good. And that goes right there. And what did we set up? 0.0375. Gram hydroxide has a 3 and that has a 2 times 2 divided by 3. 0.025, 0.025. Whoa. You guys, you've already seen it, haven't you? You've already seen the problem. You see that right there? That's what was given to me. What did I put down here? A copying error. So it should be 0.75. And so 0.75 goes right here. Right here, rather. You're going to divide both sides by 0.7. Now, 0.025 divided by 0.75. 0.0333. 0.0333 liters times 1,000 gives me 33.3 milliliters, and that's exactly what they said I'm supposed to get. Now, do you know why I made that mistake? It's to help you guys when you have ABCD answers to go back and fix your problem if you don't get one of those answers, or nearly to that one of those answers. It was a good troubleshooting training session. Actually, I just see ya.